In this video, we're going to be talking about the converse of the Pythagorean theorem. Okay, so we just went over the Pythagorean theorem. We just went over Pythagorean triples. And here we're going to go over the converse of the Pythagorean theorem. Okay, so the Pythagorean theorem says that if you have a right triangle, then a squared plus b squared equals c squared. Okay, if you'll think back to geometry, the converse is we're just going to flip what we call the hypothesis and the conclusion, and we change the Pythagorean theorem to its converse by saying then if a squared plus b squared equals c squared, then we know we must have a right triangle. Okay, so we're just kind of reversing the Pythagorean theorem. Okay, so we're going to use this to verify if a triangle is a right triangle or what's referred to as an oblique triangle. Okay, oblique triangle is not a fancy term, it just means not a right triangle. Okay, so don't get too out of sorts about that word oblique there. It just means not a right triangle. Okay, if when you perform the converse of the Pythagorean theorem here, if c squared is equal to a squared plus b squared, then we've got a right triangle. If c squared is less than a squared plus b squared, then we know the triangle must be acute. And if c squared is greater than a squared plus b squared, then we know the triangle must be obtuse. Okay, and hopefully that makes sense logically. If this longest of the three sides is greater than the sum, if the square, of the longest side is greater than the sum of the squares of the legs, that means we've got a larger angle than 90 degrees in that triangle. Okay? So when we look at number one, we can't tell if this is a right triangle by looking. There's no right angle box here. Okay? So we're not sure exactly what we have. What we do know is that the longest side is 17. Okay, so that's the value we're going to use for C. Okay? And my legs here, 9 and 12, the smaller of the two of the three sides, we're going to call those A and B. Okay? So 9 squared plus 12 squared. This symbol here means we don't know if it's equal. Okay, that's what we're trying to determine. Okay, so the little question mark there, usually it goes above it, but I couldn't put that into this document, so I just put the question mark after the equal sign. And all that means is we're questioning whether or not these two sides are equal. Okay, so I'm going to square everything. I get 81 plus 144. Is it equal to, is it not? I'm not sure yet, to 289. Okay, now I'm going to combine 81 and 144. So that gives me 225 and 289 on the left and right sides, respectively. Okay, obviously those are not equal. That's what this symbol means, the equal with the slash through it. Okay, now what I do know though is that 225 is less than 289. Okay, that means c squared, this 289, is greater than the sum of the two squares over here, 225. That means I have an obtuse triangle. Okay, don't use the look test. This doesn't look like it's an obtuse angle. It's irrelevant. Okay, maybe it's 91 degrees, maybe it's 92 degrees, who knows? Okay, we'll find out how to find that angle later on in our trig unit. Okay, but what I do know is that c squared is greater than a squared plus b squared, so I have an obtuse triangle. Okay, let's look at number two. The longest of the three sides is 20.1, so that's going to be C. This could be A or B. This could be A or B. Remember, those are interchangeable. So let's plug those values in. Okay, so 9.6 squared plus 18 squared. Is it equal to, is it not? We don't know yet, to 20.1 squared. Use your calculator. We get 92.16 plus 324. I don't know if it's equal or not to 404.01. Let's combine the two values on the left side, and I see that they're not equal. Okay, this is a little different than the first example we did, because in this case, the sum of a squared and b squared is greater than c squared. Okay, or we could say that c squared is less than a squared plus b squared. Okay, because that's the case, then that triangle must be acute. Again, don't use the look test, because to me that looks like it's maybe a right angle or maybe even obtuse. Okay, so don't use the look test. We have to use the converse of the Pythagorean theorem to answer the question. All right, one more. In 3, we're not given the triangle, we're given three sides. Okay, again, we need to know which one is C. 29 is the longest of the three lengths here, so that's going to be my C value. Okay, use the calculator. All right, and what happens there is, hey, I get 841 on both sides. Those two are equal. Okay, that means that we have a right triangle. Okay, because the a squared plus b squared value is equal to c squared, okay? So you see that in the three problems, we had one obtuse triangle, one acute triangle, and then in number 3, a right triangle. So that's how you use the converse of the Pythagorean theorem.